So we have the Laplace transformation of t raised to n e raised to at times u of t. So we have the Laplace transform. We have the improper integral of t raised to n e raised to at times e raised to negative st. And simplifying by loss of exponent these two expressions of t, we have the improper integral of e raised to negative quantity s minus a times t and t raised to nu of t dt, and we have u of t is equal to 1. And since we have two different parts of expression, we'll use integration techniques. So instead of using integration by parts, we'll use the tic-tac-toe method. So we have the differential part and the integral part. So having the derivative of our t raised to n, we have n times t raised to n minus 1, and having again the derivative by, we have n times or quantity n minus 1 t raised to n minus 2, and integrating on the integral part, we have e raised to negative quantity s minus a times t, and integrating it again, we have negative 1 over s minus a times e raised to negative quantity s minus at, and we have 1 over s minus a squared times e raised to negative s minus at, and we have negative and 1 over s minus a cube times e raised to negative quantity s minus at using the power formula. And now we will cross multiply the derivative and the integral part. So we have t raised to n with negative 1 over s minus a times e raised to negative s minus a times t here, and the derivative part cross multiply with our integral part. So we have n times t raised to n minus 1 times e raised to negative quantity s minus a times t over s minus a squared minus n, cross multiply the derivative to the integral part. We have n quantity n minus 1 times t raised to n minus 2 times e raised to negative quantity s minus a times t over s minus a cubed, and have the limits of 0 to positive infinity. So as we can see, simplifying the equation by having our limits, we have negative 1 over s minus a minus n over s minus a squared minus n quantity n minus 1 over s cubed. And from this simplified expression, after evaluating our improper integral, we can have the pattern of formula. As we can see, there is an increasing exponents of s minus a from 1 to or squared and then cubed, as well as in our numerator. So we can have the generic formula or general formula as n quantity n minus 1 times n minus 2 over s minus a quantity raised to n plus 1. So simplifying our numerator by the concept of combination of factorial, we'll have the Laplace transform of t raised to n e raised to at u of t equal to n factorial over s minus a raised to n plus 1. So this is the Laplace transformation of our given function.